Hi, in this video we're going to be talking about common polar graphs. So the three types of polar graphs are the line, the circle, and the limacon and the cardioid. The line is in its own class. The circle is of a different type, but there are four of those. And the limacon and cardioid are also of the same type, but the cardioid is called that because it's just a special type of limacon. So let's start by talking about the line class. There's only one formula for the class of lines, and that's theta is equal to alpha. So if r theta is any point on the graph, and we fix theta, and r can range from negative infinity all the way up to infinity, we get a line passing through the origin with an angle of theta. And to see why it's a line passing through the origin, let's just go ahead and solve for it in terms of Cartesian coordinates, something we're a lot more familiar with. So theta is equal to arctangent of y over x. So we can just set arctangent of y over x equal to r specific theta, which is alpha. So we get, by taking the tangent of both sides, y over x equals the tangent of alpha, which is just a number. So we'll call it a. And then solving for y, we get y is equal to ax, where a is equal to the tangent of alpha. And that's just a line passing through the origin. So when we have r is equal to theta, we get a line passing through the origin with an angle of inclination of theta. So a quick example illustrating this, let's have theta equal pi over 4. So it's going to be a line through the origin with an angle of pi over 4. And we know that this line should just be y equals x. So let's find out. So we have that the arctangent of y over x is equal to pi over 4. So that says that y over x is equal to the tangent of pi over 4. The tangent of pi over 4 is simply 1, so y over x is equal to 1. So y is equal to x, just as we hypothesized. Our next class of common graphs in polar is the circle class. So we have, our first one is r equals some number. And this tells us that no matter what theta we have, so no matter what theta we have, r is constant. Okay, so this is going to be a circle with center at the origin, and it's also going to have radius a. So what does this look like in Cartesian? Well, we know that r is equal to the square root of x squared plus y squared. In our case, r is equal to a. So if we square both sides, we get x squared plus y squared is equal to a squared. Alright, so next, let's take a look at our second part, or our second type of circle. R is equal to 2a cosine theta. So this is a circle centered at 2, 0. This is in Cartesian. But I suppose that in this case, being in polar would also work for this, with a radius of a, or I'm sorry, the center is a0. And its radius isn't negative because radii are always positive. Okay, the third type, r is equal to 2a sine of theta. So this is centered at 0a, also in Cartesian coordinates, and its radius is the absolute value of a again. And finally, we have a combination of 2 and 3 is going to be r is equal to 2a cosine theta plus 2b sine theta. And this is the most general form. So its center is AB, and its radius is going to be the square root of a squared plus b squared. So let's look at a quick example. Say we want to graph the following. So we have 3 things that we can graph. Okay. So let's first graph r is equal to 2. Now this is a circle that's center is at the origin and its radius is 2. So we'll have a radius of 2 here, and we'll draw a circle, and that is going to be it. Now b, if we have r is equal to -3 cosine theta, we know that its radius is going to be the absolute value of -3/2, right? Because this is in the form 2a cosine theta. So its radius is going to be 3/2. And its center is going to be -3/2, 0. So if we go ahead and draw our graph, we have the center at -3/2, 0. And let's see if I can draw it properly. Let's give it another go. It's going to be a circle. One last time, right? Third time's the charm. So we'll draw a circle centered at 3/2 with radius 3/2. And that is going to be -3 cosine theta. Okay. And for our last example, r is equal to 4 sine theta. So here, our a is equal to 2, which tells us that our radius is going to be the absolute value of 2, or 2. And its center is going to be 0, 2, because it's a sine. And what does this graph look like? Well, its center is at 0, 1, 2, and it has radius 2, and there is our circle, 4 sine theta. Okay, so now let's move on to our final class of common polar graphs, the cardioid and limacon class. Now, the formula for these are all the same. It's going to be r is equal to a plus or minus b cosine theta, or r is equal to a plus or minus b sine theta. Okay. Now, a cardioid occurs when a is equal to b. So that is, we have r is equal to a plus or minus a cosine theta, or r is equal to a plus or minus a sine theta. And what a cardioid looks like is it touches the graph and it goes around and it kind of looks like a heart. And let's just go ahead and graph that again to just see what we get. So it looks like a heart without the bottom point. So it looks like that, or it looks like the same thing except kicked on its side. So this is our cardioid. And this is going to be a minus a sine theta, and this is going to be a minus a. Next we have our unlooped, or what I like to call dented limacon, and this is where a is greater than b. So we might have 5 plus 3 cosine theta, something like that. And what 5 plus 3 cosine theta is going to look like is it almost looks like our cardioid, except we pull the point out a little bit. So it looks a little bit more like a kidney bean of some sort. So let's just go ahead and try drawing that again. Something like that. And then having something of the form a plus b sine theta with the same conditions, we would have a dented limacon that points somewhat upwards. So we get this weird little kidney bean shape. I would recommend going into a graphing utility and actually graphing it, because my drawings, I'm not the most artistic person, so they don't really do them justice. So finally, let's take a look at the looped limacon. So if we have something that looks like, say, 3 minus 4 sine theta, and maybe we'll look at 3 minus 4 cosine theta. Here, remember that our a is less than our b. So 3 minus 4 sine theta is going to look something like, we start here, go around, and then we have our cardioid, but we still keep going around and loop inside and come back to where we started. And if we were looking at the cosine case, the same thing, except it's kicked on its side. And that concludes the graphs and what they generally look like. So let's look at an example of actually graphing one. So let's look at 7 minus 6 cosine theta. So we know that since 7 is greater than 6, or a is greater than b, this is going to be a non-looped limacon. And we know that it's periodic with period 2 pi. So we only really need to graph theta versus r from 0 to 2 pi. And let's just go ahead and look at all the values from 0 to 2 pi in increments of pi over 4. And just remember that 0 is 2 pi, so when we do hit 2 pi, we are just going to loop back to the same value as 0 and start retracing our graph. So now that we actually have all of our coordinates that we're going to plot, let's go ahead and plot them. So 0, 1 is the angle of 0, and we go out 1. For pi over 4, we go out 2.76 about. At pi over 2, that's just straight up and down, so it's straight up 7. At 3 pi over 4, we're going to follow that line to the left and up and go out to about 11.25. For pi, we're going to go all the way to the left, 13. So let's just get rid of that arrow and plot 13. Now 5 pi over 4, we're going to follow the straight line down and to the left. For 3 pi over 2, we're going to follow the line straight down to the 7. 7 pi over 4, we're going to go directly down to the right. Remember, that's the same as negative pi over 4. And then at 2 pi, we're right back to where we started. So now that we've plotted all of our points, let's just go ahead and connect the dots. And as you can see, I might have missed a point, but that's okay because I didn't miss the point, which was that we were sketching a common polar graph. Come join me next time when we talk about slopes of tangent lines of polar graphs. And as always, thank you for watching.